Hey guys, so here is example 2 for week 6. Week 6. Yay! So let's look at it. So researchers decided researchers designed a study to compare the proportion of children who come to school having eaten breakfast in two low-income elementary schools. A simple random sample of 80 students from school 1 found that 61 ate breakfast today. At school 2, a simple random sample of 150 students included 124 who had breakfast today. Does this data give convincing evidence of the difference in the population proportions at the alpha equals 0.05 significance level? The two-way table summarizes the data from the separate random samples of children at school 1 and school 2. Calculate the standardized test statistic. Is there a difference at the alpha equals 0.05 significance level? So what we're doing is, with this two-way table, it summarizes the data that it tells you in the problem. So if you don't like reading problems, questions with two-way tables are actually really nice, because all you have to do is figure out what your proportions are actually talking about, and then you can just go from there. So the first thing that I want to do with this, because it does have a two-way table, is I want to say, what does P1 equal in both cases? What are the parameters? So the parameter for the first one is going to be, let's go with kids who eat breakfast at school 1. Eat breakfast at school 1. So then your second proportion is going to be kids who eat breakfast at school 2. Okay, so let's check out the null hypothesis. So the null hypothesis is not going to change. The proportion of the kids who eat breakfast at school 1 minus the kids who eat breakfast at school 2 is equal to 0. That's saying that there is absolutely no difference. Now, in the problem, it didn't really specify if they think one is greater than the other. It just says, is there a significant difference? So that just means not equals 0. So let's put our pieces together. So our first sample size, so kids who eat breakfast at school 1. So here's school 1. And then at the bottom, we have eats breakfast over the total. So it's really nice to look at. So kids total was 80 kids. And then the sample proportion was 61 over 80. Neat. The total kids at school 2. So we're not looking at school 1 anymore. We're looking at school 2. We have 150 total. And the sample, the number of kids who eat breakfast at school 2, is 124 over 150. And then the weird one, P hat sub C, the combined one. So we're talking about school 1 and school 2, the kids who eat breakfast at both. So that's 185 over 230. And then, of course, we also have alpha equals 0.05. And that's it for the state. Oh, probably should write state there. State. Okay, so plan. Is the data random? This one you actually do have to read, because you have to read that it says an SRS. So yes, it's random. Then we need to do N1 times P sub 1. P hat sub 1. Is that greater than or equal to 10? So this is going to be 80 times 61 over 80, greater than or equal to 10, which is 61. 61 is greater than or equal to 10. And the next one, N sub 1 times 1 minus P hat sub 1. And that's going to be 80 times 1 minus 61 over 80, which is basically 61. Or 80 minus 61, which gives us 19. So yeah, 19 is greater than or equal to 10. So cool. The next one, into P hat sub 2. greater than or equal to 10. So 150 times 124 over 150 greater than or equal to 10. Those cross out. That works. So then n sub 2 times 1 minus p sub 2. By the way, those crossed out because 124 is greater than 10. So 150 times 1 minus 124 over 150. So basically we're doing 150 minus 124, which is 45. And yes, 45 is greater than or equal to 10. So now, before we move on, we're going to go ahead and draw our curve. Woo, fancy. So the alternative hypothesis in this case said P1 minus P2 is not equal to, which means that we're going to shade to the left and to the right. So let's go ahead and do our do side. So do. Okay, so remember in this stage we're going to start by calculating z. Find z-score in table A, and then determine your p-value. So in this case, you can actually already tell that you're going to have to multiply z-score by 2. Because the alternative is not equal to, and it's got 2 different shaded areas. So let's go ahead and start by calculating z. So z equals, I'm just going to write it. So p sub 1, which is, oh, I guess we can go ahead and put that up here. Okay, so if you were to actually figure out the decimals, this would be 0.76. This would be 0.83. And this would be 0.80. There you go. So z equals 0.76 minus 0.83 minus the null hypothesis, which is 0, divided by the square root of 0.8 times 1 minus 0.8. If you want to do 0.80, go for it. You do you. And then the sample sides of the first set of data, and then do the same thing on the other side. If you're not sure what formula I am writing, it is this one. P hat sub 1 minus p hat sub 2 minus 0 divided by the square root of p hat sub 1 minus c. Sub c over n sub 2. So if you're unsure, go ahead, check that out. Super cool. Okay, but back to reality. Oh, there goes gravity. Okay, so we're going to go ahead and type it into Desmos, my favorite. We're going to start with a fraction. And that's going to be 0.76 minus 0.83 minus 0 divided by square root fraction 0.8 times 1 minus 0.8 divided by 80 plus fraction. Yeah, the fraction. 0.8 times 1 minus 0.8 divided by, what is it, 150? Yeah. And we get negative 1.26, which is like, cool. Negative 1.26, yeah. Getting in the negatives, equals negative 1.26, which actually means that we're talking about the shaded area, in case you were wondering. Because it's negative, that means we're talking about the left. So now we're going to use table A, and we're going to find the z-score. If you remember from way back when, this is whenever we would write it as P, the probability that z is less than negative 1.26, if that jogs anybody's memory. cool. If it doesn't, that's fine. Okay, so negative 1.26, we're going to use table A. So go down, negative 1.26. Gonna pretend we didn't do that. Could erase it. It's a lot of effort. So negative 1.2.06, and that is, what is that? 0.1038. Yeah. 0.1038, or if you're just writing it that way. Okay, so now we need to determine the p-value. So again, because we're talking about the left and the right side, that means that we have to multiply this by 2. So the p-value is going to be 2 times 0.1038, which is 0.2076, so 20.76%. If you were to convert it to a percentage. So let's conclude. Wow, Miss McDonald, this is exactly what we've done before, just slightly different. What? No. How does the p-value compare to alpha? So our p-value in this case is 0.2076 to 0.05. So is it greater than? Is it less than? It is greater than. So because it is greater than, we say that we fail to reject the null hypothesis. We have no convincing evidence that, and then we have to talk about the parameter and context, that there is a difference in the true proportion of students who eat breakfast at school 1 compared to school 2. It's exciting. Yay! Okay, so in the Google Classroom, you will find your problems for the week. Yeah. If you have any questions, email me, send me a message over Remind 101. Do not put a private message in the comment section of the instructions, because I don't know how to get there easily. Have a great day. Bye.